what the variables look like in Figma natively is in this table format, and at any one point in time, you will only see one table, and then you can see another table by going to the dropdown and choose another collection. But when it comes to when you want to instinctively see where this value is coming from, you have to click it and then trace. Now in this example that I'm showing, I have very few variables, but imagine in a real example, you would have to scroll a long miles, my designers say. They had to scroll miles to see which collection this is coming from. And then they had to manually trace the collection, and now I just forgot the name. So I had to go back and remember the name, that this is called input button BG. And yeah, that was a huge pain. And so this, you see that this is further coming from another collection. So then I need to trace again. So this is the reason why when we are setting up a token structure, it becomes simply just impossible to add further features, because we start to lose sight of existing features, of how the functionalities are working together. And so when you look at the same variable structure in variable visualizer, it is much more let's say visual and much easier to understand. Now, if I look at the same input button BG, you double click this, let's say you double click this input port, it will bring you to this, and then you double click here, it will bring you to this. So the entire dependency graph is super simple. And then you can see that when you have one variable selected, all the other unrelated stuff are let's say disabled and faded out. Only the relevant ones light up, so that you can visually see like what is relevant to this variable, where it's going to, as well as where it's coming from. And so this makes the maintenance and also experimentation of a variable structure much easier than if you are just looking at the table itself. So this fully utilizes a two-dimensional canvas that you can pan around and zoom in and zoom out. And on zooming out, I also have this level of detail implemented, just like strategy games that you play, like Total War, where you zoom out, you see the map of different countries, but if you zoom in, you see the details where your troop is standing. So if you zoom in, you see the connection for each of the individual variables. But if you zoom out, you see the connection that is happening between the collections. So this collection is having something to do with this, and this collection is having something to do with this collection. So that is the idea of why we call this plugin visualizer, because it turns something in a database format, from a table format, to this two-dimensional canvas, which Figma itself honestly is already a two-dimensional canvas. And then I'm so they they didn't think of the variables this way, but I had to manually build it, because this is exactly what I'm thinking. Like, Figma, come on, you're already doing it this way. Why don't you like reuse the canvas and then let us see the variable structures visually? Instead, you have to show us a table. Come on, so I have to do that, and then I did that. So, that was part of the irony, but also how in the earlier parts I mentioned, whenever I face a problem, I try to tackle that problem from the very root, instead of scratching on the surface how to cope. Because I see a lot of people coping with the table. They simply because right here they cannot see multiple tables at once. They simply export the variables from Figma to a third-party platform like Airtable or Excel, and then that way they can open multiple tables at once. But that is coping. That is not like solving it at the very core. You still don't have a GUI, a graphical user interface, so to say, you still have this database format. We are doing the direct variable export in the variable visualizer plugin itself, because one feature that I find lacking right now is that there's no way for you to export these collections natively yet. They mentioned that in this schema, but we don't know when that is going to be launched yet. It's right now in the closed beta test, but
Understood, yeah.
How people are exporting is that they open variable visualizer, they export the full data as JSON, and then you can save it wherever you want, be it a GitHub or local. You can check, like, for example, right now, this is the JSON that is exported. You have different collections. This collection is called the primitive, and then you have this many variables, and each of the variable in the primitive collection has their own value depending on different modes. And then you have all the collections. So now it's the semantic collection, and then you also have the component collection. Right now, the 3 collections that I have. So I see a lot of people also export their variables in the DTCG format, which will split each mode into different files. So for example, if I have 2 mode right here, you're gonna end up with 2 files. But in variable visualizer, we are condensing all of the data into one JSON export, so that it makes it much tighter for the storage of the JSON, and making the working with the JSON, either you're using large language model or the developer himself, a nicer user experience. For example, let's say that I want to name all of these, not using the dash, but just using the slash. We can right click and rename all of these, and I match the dash, and then change all of them to this, and then I can hit rename, and this changes everything in one go. You can just drag a selection box to select all of these, and then hit Command R to open the rename, and say if I want to change the BG to background, that way. So everywhere you see the BG got changed to the background. And there is also another way that you can do this, which is to use AI. It's the same, that you only have to have this collection selected. So now you see, without any collection selected, you see all collections. This is the context. But if you select one, the AI can focus on this one collection, and then you can ask it to give you different naming for all of these variables, to be using CSS namings, right? To be using CSS naming conventions, so it's more understandable by devs. So let's correct a few spelling mistakes, and then let's send it. So as the AI is working, you will see that there is a thinking progress, and then once it's done, it's going to make the changes, and then you can see where the changes is coming. There is this incoming changes in a panel that you can see what are the stuff that it changed. And then you can either reject or accept all the changes. So now let's say that it changed the input radius to input border radius, etc. You can see it right here. I can also click this, and then it will bring me to the exact thing that it is mentioning, so which got blocked by this panel
Cool.
itself. Yeah, so let's say input blur now is called input backdrop blur.
So it's basically using the CSS properties to
The
name
input
the
stroke
variables.
Stroke is now called the input border, because in CSS you don't have stroke. So a lot of these things you have to do manually, and then human mistakes can crawl up. Some maybe this is called button stroke radius. This is called input border width. That's what happens with humans. But with AI, it's able to change these namings conventions pretty, let's say, consistent. For example, if we the input itself is going to have different states than, let's say, a button. This might be let's say, input idle. This is going to be shared, but the input would have, like, let's say that it is active, somebody's typing there, or that it is at let's say, focus. Some of these are probably not going to be shared on the button, because on the button you will have pressed, uh, and then definitely not active because it's not an indicator. So then we can call this component itself just the input, and then uh, we can actually just duplicate this, and then call this the button component. And it can have different uh, modes. Let's say this is the pressed, and this is how you can actually differentiate what each of the component behave like. They can behave entirely differently. And then if you want to further distinguish between the actual colors, the border colors, you can definitely let the AI do that. And then, but now the colors are a bit the same. So let's ask the AI to change a bit of the color, so that they appear more, let's say, realistic. I'm gonna say I'll just use the Mac Whisper for this because it's faster, and then I will now prompt it like so. I will say, "Hey, can you please change the input and the button collection uh, to make each of the different modes using a different aliasing, using a different color that is most fitting for the input and for the button, for the exact mode that it is for each different mode, for each different mode, let's say." Yeah, let's send it. And again, so then you wait for the AI to do the work. It doesn't have to be always, let's say, perfect on the first go. Well, let's see what happened. Exactly. So it cannot determine which color variable to alias to. Uh, so it needs to clarify the requirements, and it is asking me what exact color do I mean. So I got, yeah, I think so. Yes. So I didn't give it the context of the, you see, it read the input and the button itself. So let's actually start a new chat and then give it the context of everything. In this case, it will be able to see the not only the primitives but also the semantics, and so then it's able to do the aliasing much better, because previously I only gave it the access to these two collections.
Yeah.
So
There are
it
not
does.
much colors there.
Yeah, exactly. And also the thing is that currently the large language model is pretty cautious. It doesn't want to break the stuff that it doesn't understand. And so now it's is having much more confidence, and then it did the thing that I asked for. And so you see now, I think if I put them two side by side, there is perhaps a little it's gonna be a little difference. You see, so the on
Yes.
press, the button background is the input background is using a different color than the button sorry, than the, wait, is it called the same? I think I probably
Yeah, we didn't change the name. I guess when you copy,
forgot
you
to
just change it.
change the name. I forgot
Maybe
to change.
that's also.
Yeah, let's actually get rid of the input. So these are gonna be instead called the button. So, and one of the cool things is that we can actually roll back. If I hit Command Z, I can
Amazing.
actually, yeah, I can roll back to before the AI has made any change, you see. So now I will actually change the name from the input to button, so that the AI has better understanding, and I will just copy this and tell it to do the same thing again and give it all the context. So it then because I think the behavior is based on the naming of these tokens. If you call this input, then it's
True,
not a
yeah.
reason. Super good, yeah. But now let's see. You see now it made much more changes, and look at for example, if I put the two side by side, you will see that these colors are totally different from the text color from the text color on the input and the text color on the button itself. It's yeah. So and also the icon color, etc. I can create a color scaling, yes, but that is not the math operator itself. It's gonna be the color scale generator right here, and then that is able to output to a collection that you select, and then it's able to generate the number of steps that you specify. For example, if I say 7, then it generates a 7 color, and then you can also specify the naming format. So say these are my in indigo, then everything is gonna be like this indigo, and then yeah, so you can also toggle the hue shift. It's slight changes having the hue shift or not. So let's say see if I can actually make the difference larger by choosing a different color. Uh, yeah. So here, without hue shift, you will see that this right here, the second color here, is towards the yellow. But if I turn on the hue shift, it's much more vibrant green. And
I see.
so yeah, this is where, and then you can also use different algorithm to generate. So it supports currently the OKLCH, the CAM16 UCS, and you see each different algorithm gives you different results. Contrast operator, take any random background, let's say this, if used for the background, what would be the optimal color that goes for the foreground? So then let's say add a variable here, call that the foreground, and then you will see that if I have this connected, it will say that the white is the better candidate. But if I connect it to this, then it will say that the black is the better candidate. And of course, you can also change manually the candidate color yourself. So you can also, let's say, just double click here and choose, let's say, any color that you want. But uh, you can also drag any of the connect to any of the existing colors from your scale. So let's compare between this color and maybe this color for the two candidates, and then this one wins out at a APCA score of 76, which passes the contrast checker for APCA standards. If it fails, it will show, let's say, it would, for example, if I go this, it will fail, and then it will show red mark. Yeah. Let's say if I have a frame, and then on top I have some text, and then I will connect these. I will have the text layer selected, and then I can drag the text layer inside, and then I can say connect to the fields, and then this text field color is connected, and then if I drag the frame blah 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 to here, and then I can connect, let's say, any color here to the fields of the frame itself, and then it's connected.
Now and next.